All right, so here, if we were to look at this, there are two scenarios here. As on the way up this like a semicircular hill, and on top of the semicircular hill. So if I were to draw a free body diagram on the way up, what's the obvious force? Yeah, Fg is the obvious force here. So here's the Fg, right? So Fg, now you have what? What other force do we have? F normal, right? Which way is F normal? Radially outwards. So that's your F normal right here, right? And does this have friction or no friction? It does have friction, mu sub k right here. Therefore, which way is friction? Tangential downwards, right? So this is your F friction. Okay? So this Fg can be broken up into its Fg tangential and Fg radial. Okay? So here, so this is Fg radial, and this is Fg tangential. And you could think of this as your angle theta, because this theta and this theta would be congruent because of alternate interior angles are congruent. And we're going to consider the direction of motion to be positive tangentially this way, and we're going to consider direction radially this way positive. Okay? So if I were to look at sum of all forces in the radial direction, right? So here, sum of all forces in the radial direction, this is radial, that is equal to ma radial, right? And then sum of all forces in the radial directions. How many forces do I have? I have 2, right? That's Fg radial plus F normal. So when I set them equal to each other, my ma radial is equal to Fg radial. Is that positive or negative? That's positive direction. So Fg radial. About F normal? That's definitely negative because it's pointing away from the center, right? So this is my setup. Okay? So you can actually solve for F normal if you want to, right? So you could say F normal is equal to simply Fg radial, which is Fg times cosine of the angle theta, right? Right? Minus m times v squared over r. So this is your F normal. Right? And then let's take a look at F tangential. Right? So sum of all forces in a tangential way is equal to ma tangential. Okay? And how many forces do I have in tangential direction? 2, right? That is Fg tangential, right? Plus F friction, right? Therefore, ma tangential is equal to, here, my Fg tangential, positive or negative? Huh? Negative FG times sine theta. And friction is also negative. Okay? So if you solve for frictional force, my friction is equal to simply, right, negative FG sine theta minus MA tangential. Alright, so this is another way of solving it. Now what if it's at the top? When it's at the top of this, how many forces are acting on this? 3. Very good. Which are FG going straight down, so this is FG, and F normal, which is up, straight up, right? And F friction is acting to the left, right? So here is your F friction. Okay. Again, I will make the direction of motion to be positive, so tangentially to the right and radially down as positive. So here, sum of all forces, here's the radial, right? So here, sum of all forces in the radial direction is equal to MA radial, and sum of all forces in the radial direction, I have 2 FG plus F normal. Therefore, here MA radial is equal to, again, FG minus F normal. So here, again, F normal is equal to, right, FG, so MG minus MA radial, or simply, you know, F normal is equal to MG times G minus V squared over R. So you could do that. Then for tangential, right, we have sum of all forces tangentially is equal to MA tangential, and sum of all force tangential is equal to how many forces? Just one, F friction, huh? So when I set them equal to each other, MA tangential is equal to, friction is negative. Okay? So you can say, I guess you could say you could think about this normal force here. So my frictional force is equal to negative MA tangential. But you know your friction is mu times the F normal, and this is your F normal that you can plug into your equation here. Alright? So that was A and B. What about part C? Part C asks, write down an expression for maximum speed the mass can have in each case. So what happens when this thing goes too fast? Right here. It would fly off, right? When it flies off, it avoids the contact between the surface and the block. So what's my normal force when it starts to fly off? 0, right? So my F normal, right, approaches to 0 as it goes faster and faster and faster. So what happens when F normal goes to 0? That means, right, that means my 0 here, so if I bring this here, 0 is equal to simply FG cosine theta minus mv squared over r. Alright? So if I bring this to the other side, I get mv squared over r is equal to mg cosine theta. And notice how my masses can cancel out. So my v is equal to square root of rg cosine theta. I cannot go faster than this value, or else if I go faster than this value, I'm airborne. Does that make sense? Alright, I'm airborne. So don't drive faster than that. Similarly here, if I'm here, notice again, if my f normal approaches 0, right, then this equation becomes 0 is equal to simply m times g minus v squared over r. But if I divide both sides by m, this goes away, right? So my v squared over r is equal to g. So my v is equal to square root of rg in this case. If I go faster than this at the top of the hill, I am airborne. Is that good? Alright, I'll stop there today.